Welcome to this class. Today I will show you how to work uh, your hardware lab using some kind of software. So today's class I will demonstrate JK flip-flop simulation, and let us start. So the online platform that we will be using for your simulation of your hardware labs is known as tinkercad. If you just see, name is tinkercad.com. If you go on there, you need to log on with your email. Okay, so I have been logged on here with my email. Okay, so use your Google account or your Gmail simply to log into this tinkercad and go on the circuits. If you go on the circuits, you have seen that I have simulated numerous types of circuits there. Okay, so let me show you how to simulate your circuit there. So you go on create new circuit. At this particular point in create new circuit, you will see that you have all the components here. So let us start with the simulation. Okay, so for simulating JK flip-flop, the IC name that is available on tinkercad is 7473. If you write there the 7473, you see this is the dual JK flip-flop, so it has two JK flip-flops, okay, in a single chip. So let us pick this IC. Another thing is we need to place it in a breadboard, so write down breadboard. So you take the breadboard small because we will be simulating only a single IC. So this breadboard, and you know where to place this IC here. So this is actually the actual IC that you have gone through in your labs, hardware labs, right? You see the U-shaped of thing is there. So this is the pin number 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14. So total 14. And you have don't need to look at the pin diagrams because they have named it. This is the clock for first JK flip-flop, then this is the reset button, this is a K, okay, and that is the power port, there is another clock, another reset, another J2, this is the inverted output, Q prime output, so K2 ground output, and if you just put your mouse there, you will get these things, right? Okay, so right now what I will do, I will make I have put the thing on the breadboard. Now I will make some connections. Okay, I'll make some connections, and I will place another equipments. Okay, so for the clock I need to put here function generator or signal generator. So let me work with this thing. So start with a function generator. You write down function. So you'll come here, there is a function generator there. Okay, so we need to put a square wave. There are square waves, sinusoidal wave, triangular waves are there. Okay, so we need to generate a clock pulse. Okay, so let me simulate this thing first. Okay, this thing maybe we will discuss a bit later, but we have a function here. Let us generate the clock pulse first, right? So in order to observe the clock pulse, we need an oscilloscope, right? So you write oscilloscope. So you see the oscilloscope is here. So simple, you can drag as many as oscilloscopes there. Okay, so simple thing, you just click on your left click of your mouse, you drag that positive wire, you come it here. Okay, that is the connection is made, and the ground this node. So simple. So if you run this start simulation, okay, you will see that there has been 1 kilohertz signal is going on there, right? So let me make the signal a 1 hertz. Okay, there is a 1 hertz signal, and if I choose the time frame, right, make it 500 divisions per millisecond. So now you can actually have the observations of your square waves, right? So that is the DC offset. Okay, if you make that DC offset 0, let me make it to 0, make this DC offset to 0 volt, you will see this is just the square waves, right? The square waves are coming. You can make it a sine wave like this one. There's the sinusoidal waves are coming on, and a triangular as well. So it means actually now you have 5 volt peak to peaks. Okay, so the whole scale is if you just check it here, the whole scale is with 10 volts. Okay, so that is the 5 volt. Okay, half of 10 volts. Okay, 10 volts peak to peak, 10 volts this side, 10 volts this side. Okay, so that is 5 volt and 5 volt. Okay, so that's the scale. Okay, so similarly we'll be having this thing, square wave. Now how to generate clock pulse using these square waves? Okay, it's really simple. You just make your DC offset voltage 2.5. then what will happen, the DC of offset voltage will move your square wave a bit high, so it will become 10 volts, and it will become from 0 to 10, right? 0 to 10. So that is actually just like your clock pulse that you have to use here. So we are good to go with our clock signal. Our clock signal has been generated. Okay, we have seen how to use this signal generator and as well as this oscilloscope here. Okay, now the next thing is to give the connection to these things. Okay, so if you click it and if you delete these wires, okay, you click it, you delete these wires. Okay, now you need to go for a power supply. Okay, so there are numerous ways to give power supply in this breadboard. Okay, you can use this power supply, you can use this thing. Okay, then you can control the current and the voltage. Okay, but for me, I am not that much good at actually this kind of knobs, right? Because I cannot adjust it via these knobs. Okay, so I avoid this thing. What I did actually, instead of that, I put an Arduino. You can actually code here in the Arduino everything. I put on an Arduino. Okay, and I will just use that 5 volt supply from that Arduino. Okay, and to limit the current, because you know that each of the pin, okay, probably the 5 to 10 15 milliamperes are the rated current to pass through these pins. So I will use a 1 kilo ohm resistance, so that the current will be actually limited to 5 milliamperes. So that's way I can have a constant voltage and current supply. Okay, I actually don't recommend to use this thing. So let us start with the Arduino. Okay, so you write Arduino here. So you see that Arduino R3 board, I will use this thing. So that is the Arduino R3 board. Okay, so now let me make some connections. Okay, so you can see that here is a 5 volt and a ground connection. Okay, so let me put that 5 volt supply here. Okay, and that will be our main supply. So just here you can see that that is the supply, and they are actually the power. Okay, so let me use it something like that. Okay, so the next thing is there should be a ground. So from that ground I'll be using another node here. Now actually this is actually the supply. Okay, I can short the voltage rails positive VCC and the ground here. Okay, so what I will do right now, I'll put a resistor to limit the currents, okay, to control the currents in between these two nodes. So let me put a resistor between the VCC and ground. So if you write here a resistor, so you can see that this is a resistor, typical resistor. So you can rotate, actually you select this thing, drag there, and if you use this button, then you can rotate. Okay, so just put it here, something like that, and it has been placed. So this wire, so let me delete this wire. This wire is okay. Let me use this is the 5V VCC, so red colored wire is used here. And from this node, actually from this terminal 1, from the resistor, you connect it to ground. So the ground connection has made, and actually colored that thing in black, so that is the ground connection. Now you can actually short it from the both sides. So let me put the resistor somewhere here. Okay, done. So now actually I will short this one to this one, so that is the VCC, so red, and this one to here, so again make it red. So now this whole rail, it becomes my VCC, right, my 5V supply. And for ground, just do the same thing. This node is the ground, so you connect it here, make it black, and for here again that is shorted, so make a connection here, that is also black. So that's how my whole, now this rail to this rail, they are all my ground nodes. Okay, now I need to give the power. You see that the middle position, the pin number 4 is the power, so it should be served with the VCC. This is my VCC rail, right? So simple, the power, you drag this thing to this node and make it red, so that is actually the power has been served. Similarly here the ground, so connect this to this red and make this thing to black. So now the IC has been served with the powers, right? Now for the clock, as I have prepared the clock, okay, so let me do this thing. So for the oscilloscope feeding, let me use a different color for oscilloscope probes, as this is the oscilloscope probe. Let us use the orange. Okay, and this is supposed to be ground, and we need to make a common ground connection. Okay, so you use it here, you make it black. Now from here to another node. Okay, just for the time being, let me delete this thing. Let me connect it to here, so we need to make a common ground and another node to here. So now all the grounds have a common. Okay, now similar thing, let me delete this thing, and also this clock signal should be passed, this clock signal should be passed to pin number 1, right? you can see that this is the clock one. So name it orange, and the same thing from this clock I'll be passed here in the oscilloscope, the same thing, orange. So this orange is actually the clock, right? I'll see the clock signal here, and the clock signal is applied to that chip. Okay, so pretty much simpler. Now the next thing is the reset. Okay, for the reset, I hope that thing you know from your DLD theory course. Okay, so the reset is will be in the VCC, and we have a K and we have a J. Now we need to apply for these two, and there is an output, and that for that output will be passed through for another oscilloscope, right? So let us make the connections. We need to have some switches for that. Okay, so if you search here, you will get some switch. So we will be using this slide switch, so it's very handy. I will show you the mechanism of this slide switch in brief. So one for the J, another one for the K, right? So if you check it here, the slide switch, there is a terminal 1 and there is a terminal 2. Okay, so we will connect and there is the common terminal, right? So when the switch resides here, so it means these and these two, they are actually shorted. Okay, and when the switch resides here, that means this common and this one, they are shorted. Okay, so actually, as you know that our inputs for J and K for the flip-flop, they will be swinging from 0 to 1, right? So one terminal will be connected to the ground, one terminal will be connected to the VCC, and we will be swinging. So that's how we can make it from 0 to 1. Okay, so let us do this thing. Okay, we will actually make a convention. We will for this side, for the left side, we will make it with the VCC. So as it is connected with the VCC, so red, and this side will be connected with the ground. Okay, so as we are connected with the ground, black. So that is the convention we are making to actually simulate for our better understanding. Okay, so similarly here the left side is for VCC, that means logic 1, right, for that particular switch. So if you see that here, this side, left side, I will be going for VCC. So shorted, so red, and this side is grounded, so black. Now that is our K, right? This one is our K1. So I will take this K1 and I will connect it to the common, right? So the common node has been connected with this K1, that is our K switch, and that is our J switch. Okay, so J switch will be from here to connected here. Okay, so that is J and that is K. Okay, now the output 1, it should be, we will be using another oscilloscope. Let me find out another oscilloscope. So another oscilloscope just beneath your this one, so that we can actually compare. This is our input and this is the output. Okay, so similarly for output is coming from this. This is the output 1. Okay, for output so that is another, as we are using the probe, orange probe, for actually measuring the outputs and input clock, right? So the next thing is our ground, the negative ground. Just connect it with the ground. The ground is the inner node, so make it black. So now that's the whole connection has been done. Okay, So let me start to simulate this thing. If I start simulating, let me give it some time to have the simulation here. Okay, for this one again make them in the same scale, 500. So you can see it here what's happening actually in these two nodes. Okay, you can see that both, this is our J and these are K, both are connected to now the VCC, right? The VCC. So 1 and 1, right? When they are both 1, there will be in the toggling state, right? And you'll see that the previous state 1, next is 0, 1, then 0, 1 and 0. So that's the, based on the time that's happening, right? And this is actually level triggered toggling option is going on there, right? Now let us make other operations, set, reset and other operations, right? So if I make my K 0, so K is 0 and J is 1, right? J is connected to the VCC and K is connected to, so you can see that in the scale this is 20 volt and this is actually having the 10 volts, right? So that means this is set operation, right? That is 1, right? Set operation. Now similarly let us show the hold operation, if it holds the previous state or not. So just similarly I will make the J also 0, so you can see that it holds the previous state, right? It holds the previous state. Now let us change a bit and make a reset operation. So if I give it the K1, you can see that drastically it becomes 0. Okay, and you can check now, this is actually the scale changes, right? The 10 microvolt. Okay, so that is some 10 microvolts, right? So there's a tiny amount of it, it is closest to the 0 volt. Okay, a offset is shown, okay, in the oscilloscope, but it tends to 0 volt. So it is actually the J is 0, that is connected to the ground, and K is 1, so it is actually showing 0. 10 microvolts is actually tiny amount of voltage is there, so 0. Okay, so it's now if you make this thing again 0 0, so you see that 10 microvolt scale is not changed. Okay, so that is also in the hold mode, right? Now if I make again that thing 1, you will see that it again start with the plus and the scale has been changed to 20 volt. Now this is actually 10 volt, right? If this whole bunch is there are 1 2 3 4 5 stages are there, right? So now this is actually your that kind of thing, so plus 5 volts are going on there, right? So that's how your whole thing works. Okay, now this is in the set mode. If you want to do the hold again, okay, so this scale doesn't change. Okay, so if you make this thing, it will drastically it will change to 0. Okay, and then the scale will change that now that this is 10 microvolts, so still again it is 0. So this is the reset operation of your JK flip-flop, and if you both want, then it will have a toggle operation. Okay, so you will see all the operations you can actually do using this chip. Okay, and you can observe using oscilloscope. This is actually a digital lab of your hardware lab, digital version of your hardware lab, and you can actually do your tasks here. Okay, now you can have fun, you can simulate these things. Okay, everything you can do. Okay, the way I have shown you, you can do this way for powering your IC, but you can use also the power supply here, but power supply is very difficult to adjust, okay, the current voltage by moving the knobs. Okay, so it's better to use this way. Okay, but if you are feeling comfortable to use the power supply, then you can use the power supply. Okay, it's not a matter. So now actually by this way you can actually connect your circuit, you can observe your circuit. Okay, now your task will be very simple. You need to build this connection. Okay, you have to use a D flip-flop and a XOR gate, and you need to make a T flip-flop. Okay, so that is your task. So actually this is very easy. If you have a laptop, if you have a computer, then you can actually do this thing. No need to install any kind of software, just you got this circuit, you simulate this circuit. There is a D flip-flop there, the D flip-flop IC is 7474. okay, if you write here 7474, so you see that is your dual D flip-flop. And for XOR gate, this is actually 7486 if I am not wrong. So you see the quad XOR gate is there, so you can actually simulate this thing. Okay, so try to simulate this thing, that is your task. And if you find any problem, then you feel free to ask. Okay, so best of luck guys.